so I think it was okay. Okay, so for this chapter, we have for this week. Hopefully, I'll have time to cover the circuit analysis method where we have two. We have the node voltage and we have as well the mesh analysis method lah. Okay, so the first for today, I'm going to cover for the node voltage method lah. Okay. Alright, so we have this lah, node voltage and mesh current. So for the node voltage, you need to recall this lah, KCL. I think that you remember lah the KCL, right? So for the KCL, I think that it's just I again browse through lah what is the KCL again. So KCL is actually the algebraic summation of current at node, which is the summation is equal to 0 lah. Okay, so the equation for that is actually the summation of current is equal to 0. Okay. Or the other definition we have for the KCL is actually the summation of current entering the node is equal to the summation of current leaving the node. So the summation of current leaving the node is equal to the summation of currents leaving the node. So for this entering and this leaving current, I always like to use the convection sign lah. Okay, convection sign, which is for the entering, I like to use it as a positive current, and for the leaving, I like to use as a negative current lah. Okay, for example, like we have this like a node, right? A node voltage, like let's say this one is a V1 lah. Okay, node 1. Okay, so we have this current which is coming from this direction. You can see my arrow, right? And then this one is coming on that, and then this one here lah. Okay, so this one we call it as a entering, and this one we call it as a leaving the node. Okay, so this is the node. Okay, so you need to put the convention sign here. Okay, the entering, like I said here, the entering is positive current, right? So just put the positive current here, the positive sign, and the leaving you just put the negative, and here is leaving, right? So just put the negative. So the meaning for the summation of current entering is equal to summation of current leaving. So you can just put the equal here, and then just put the positive current here and the negative current here. Let's say the positive is I1, and here is I2, and here is I3. So what you can just put where's the summation of the positive current, and this one is the negative current lah. Okay, so positive you can just put I1, and then for the negative, which is I2 plus with the I3 lah, because we have two current which is leaving this node. So you can sum these two lah, which is I2 plus with I3 lah. Okay, so you will have this equation lah for your node voltage lah. And then after that, when you have this the current, okay, you need to convert this into the voltage lah. Okay, so regarding to the Ohm's law, right? So V equal to IR. So for the current, what you have is I equal to V over R. So you need to change this I into this lah, V over R lah. Okay, I'm gonna show you on the next slides lah. Right? Okay, guys, do you get it? Okay, so we also for the nodal analysis, the term of the node voltage referring to the potential difference between the two nodes lah. Okay, the potential between the two nodes is actually the potential between the two nodes is actually okay, so you know that the potential of the two nodes, right? Let's say this one is V1 and this one is V2, and then you have here is R. Let's say R1. So the potential difference between the two nodes mean that follow the directions of the currents lah, right? So let's say your directions of current this way, okay, this way. So what you have to do, V1 minus V2 over R1. So this is your node voltage lah. Okay, so we call it as the potential difference between two nodes of a circuit. So the two nodes is actually V1 and V2 lah. So we provide the general procedure for analyzing circuit using node voltage, and then the important things that you need to have your reference node lah. Reference node usually the ground lah, which is 0. Okay, so the reference node symbol for the reference node usually we have this lah, common ground, and this is, we call it as a chassis ground. So we usually name this as a reference node lah, which represent the 0 lah. Okay, so which is defined to be 0 lah. Okay. Alright, so the important skill that you need to know when analyze your circuit with the node voltage techniques, you need to know how to control the current arrow or your current directions. Like as I show you, the first one, the KCL, right? The directions of current through the nodes, where whether it's entering, whether it's leaving lah. So you need to make sure this arrow. You can just put any directions that you want on your circuit, but you need to know lah which directions that you are using for your circuit, so it's easy for you to analyze the circuit lah. For example, this one, right? And then you need also to know that the arrow points is actually the positive sign on the resistor voltage. Okay, means that, let's say here, okay, you can see from this figure, the arrow is pointing this way, right? So means that your sign for resistor, your voltage for the resistor is actually starting from the positive lah, based on the directions of the arrow. Okay, so here this one is, the node is VA and VB, so means that for your VR it's actually equal to VA minus with VB lah. Okay, and same goes to this one, because of the directions of goes this way. So you just started from the following your arrow lah, VA minus VB minus with VA lah. Just follow the directions for your currents. Let's say like here A and B, so just start VA, VB, like from this one, VB minus, like say here C, VB minus C lah. It's just like that lah. Okay, because the node voltage, we control the directions of the current arrow lah. That's really important. That's why we have the KCL, which is equate whether the summation of entering is equal to the summation of leaving the node. So you need to note this lah. Alright. Okay, so we move on to the next slide. So this is actually a few steps how you determine your node voltage method lah. First, we choose a node as the reference node, which is reference node is actually the ground, chassis ground, the common ground lah, which is 0 lah. Okay, and then we need to select our voltage, which is as a V1, V2. Okay, so the voltage are referenced with the respects to the reference node lah, and then we need to apply the KCL, which is the summation of entering the nodes is equal to the summation of negative current lah, which is leaving the node. Okay, and then we need to use the Ohm's law, like I said to you before. So the current is actually I equal to V over R lah. Okay, and then we need to solve the resulting simultaneous equation to obtain the unknown node voltage. So this simultaneous equation, if we have two equation, we can solve it using the elimination method or the substitution method lah. But if you have three equation, you can still use the substitution method. But I'm just suggesting you to use the metric method lah, where we have the Kramer rules, right? So you might need to use that lah for three equation node lah, where when you have three equation means that you have three nodes on the voltage lah. All right. Okay guys, are you with me?
Yes, teacher.
Still boleh faham So do you understand? Do you have any question to ask before I proceed with this slide? Do you have any question? Tak ada So I'll just proceed with this slide lah. Okay. So nodal analysis. If you are given the following circuit, how can we determine the voltage across the resistor, the current, okay, the voltage, the current, and also the power lah. This is like a common thing that the circuit, you need to know about the circuit lah, the voltage, the current, and how many power do your circuit have, okay? So like for example, if you have this circuit, what are the things which we need to know in order to determine the answer for this lah? Okay. So for this one, we have these two. This one we call it as a non-reference node lah. For node 1 and 2, we call it as a non-reference node. And as I said before, the reference node here is actually the ground lah. So we call it here as a reference node. So for this circuit, the first thing that you need to put the reference node here, and then you need to determine your node lah. Like for this circuit, you have this node lah, these two nodes, which is 1 and 2 here. Okay, so from this node, okay, so in this diagram, node 3 is defined as a reference node, and node 1 and node 2 here, we define as a node voltage, where we label that as V1 and V2 lah, here V1 and V2. So we use this V1 and V2 when we want to deal with the equations lah. We want to come up with the equation for these two. So from this circuit, it's obviously that you have two nodes, right? You have two nodes, which is you have V1 and V2. So means that you need to find the value for this voltage lah, where V1 and V2. So the how many equation that you note? Obviously, you have two nodes, so that you need to have two equations lah, in order to solve for V1 and V2 lah, okay? Because the question asks you calculate the node voltage, where the node voltage here is actually obviously this V1 and V2 lah, V1 and V2. So you need to find the value for this two voltage, where you need to have two equations lah. You need to come up with the two equation based on this node 1 and node 2 here. Okay, so your node 2 and node 1. Okay, first, like I said in the show you on the previous slide, the first important thing that you need to know when you have this circuit is your current directions. All right, your current directions, because you want to do the summation of the current, right? Summation of the current, where summation entering the node and summation of the current leaving the node, where the positive is for the entering lah, and the negative is for the leaving the nodes. All right, so like for this example, it's already draw the current directions for you, right? Like for this one, node V1, so you have the node 1 here. The current directions is actually this one is entering, this one is leaving, and this one also is leaving lah. So you need to put this current inside this lah, for the summation for the entering equal to summation of the leaving current lah. Okay, so I use this convection sign lah. Okay, so it's easy if you can just write this back again lah, where your current your current directions coming lah. Okay, so you have the positive equal to the negative, right? So for the entering, I just put positive, and for the leaving this node, I just put the negative sign lah. So what I have to what I can write here, like for the positive, I have this I1 which is equal to 5. So I just write here 5 lah, and equal with the negative sign, which is I have I2 plus with I3 lah, because it was summation, so I need to just sum these two current lah, I3 plus with I2. Okay, so for this I5, I already have the value for the current, which is 5 lah. But for the I3 and I3 and I2 here, I need to use the Ohm's law where I is equal to VR. So the node voltage is actually the difference between these two nodes lah. Okay. So what I need to come up with this equation is that for this I3, right? For this I3, the node is with this one and this reference node lah. So what I have to do is V1 minus with 0 here. V1 minus V0 with the R, which is here, if you use the Ohm's law, R is actually equal to this 2 lah, 2 plus with this I2, which is here, these directions, okay, which is V1 minus with V2 over with the 4 lah, the R, okay, 4. So this is the equation that you have lah, okay. So you have this, and then you write this back again lah. And then once you have this this equation, you can just simplify, right? You need to simplify in order to get equations lah. Okay, so how to simplify this equation? So I think that most of you know how to do this, right? But I'm just show to you, it's just a mathematics things lah, right? So what you have to do is that in order to get this equation, simplify this equation, what you have to do is you need to kill this denominator, right? In order to kill this, you need to times it with 4, right? Or if you have another easier method, so you can just use that lah, all right? Okay, so I think this is a very conventional method lah. In order to kill this denominator, you can just times this with 4, where here you will get 20 equal to so just kill this one, so you get 1. So you have V1 minus V2 plus with, and you kill this one, you get 1, and here is 2. So you will have 2 V1. And then for this, you will have 20 equal to, just sum this one. So you have 3 V1 minus with V2. So you have this as your equation 1. Okay. Right, so you have this as your equation 1. And then after that, we go with this node V2 lah, which is here. So I just write back again to you because we need to sum the entering and equal to the leaving current lah. So you can just put this I2 and I4 is entering the nodes, and I5 and I1 and I5 is leaving the nodes lah. So what you have is, you have I2 plus with 10 lah. I2 plus with I4 here equal to I1 plus with I5 here, which is, this is the summation for the current entering, and this is the summation of current leaving the nodes lah, leaving the nodes here for V2. Okay, so you just have to convert it into the Ohm's law lah. Okay, for I2, obviously, where is the I2? I2 is here. If you just follow the current, it's actually this way, right? So the I2 here is actually V1 minus V2 over 4 lah. Okay, so V1 minus V2 is over 4, and you know that I4 here is actually obviously is 10 lah. I4 here, and then we have this I1. I1 is actually equal to 5. And then plus with this I5, I5 is this way, so V2 minus V0 over 6. Okay, so V2 minus V0 over 6. And this one is same like this one. If you want, you need to simplify this equation, okay, in order to solve it using the, in order to have the simultaneous equation, right? Okay, for this one, in order to simplify this, you might times this with 24, and you can have these equations lah, right? Where if you kill this one, you will have like 6v1 minus with 6v2 equal to 240, 200, no, plus with 240 equal to 25 minus with times with 5, I think it was 120, right? And plus with this one, you will have 4v2, and then when you simplify, you will have these equations lah. All right, so this is we define as equation 2. Okay, so you already have two equations lah, where you have this equation and you have this equation. So when you have these two equations, you can solve to get V1 and V2. Like I said before, you can use the elimination method or you can use the substitution method lah. All right, this is very mathematics lah. So when you solve for that, okay, you can have V1 is equal to 13.33 and V2 is 20 volts lah. All right, so let me show you the example how to use the elimination method lah. I think that all of you an expert with this lah, kan? But I just show for this one lah, okay? So for this, you have these two equation, right? So this one is equation 1 and this is equation 2. So what you have to do is for your elimination method, the name is elimination method. So the first thing you have to do to get one of this value for V1 or V2, what you have to do is that you need to eliminate each one first. Okay, like for this one, I think that easy for us to just eliminate this V1 first. Okay, so like just write this equation back again. All right, so 3V1 minus V2. Okay, so what we have to do is like I like to eliminate this V1 first. All right, what I have to do is that I just have to put the subtract lah. So I need to subtract 3V1 minus with 3V1. So I kill this one or I just eliminate this V1. So now I can get only this V2 in order to get the value for this V2 lah. All right, so negative V2 minus with minus V2. So I can get this as a 4V2 equal to 20 minus with minus 60. I have 80 lah. And then for V2 is 80 over 4. So I can get V2 is equal to 20 volts lah. All right, so then I have this value. So I can substitute V2 equal to 20 volt in, let's say I want to substitute in equation 1 lah. Okay, I want to substitute is in equation 1. So what I have to do is that I just substitute the value. Okay, 3V1 minus with 20 equal to 20. Okay, so 3V1 minus with 20 equal to 20. So 3V1 equal to, just bring this here. So you have 40. V1 is equal to 40 over 3 volts. So this is your answer lah. So this is very important part when you do the test or final exam nanti. So you need to show this method lah. You need to show this method so that you have a marks for that. Okay, I know that you can use your calculator, okay, to just straight away calculate this value to get the value, but still you need to show the solution and the method, what method you are using lah to get a marks. Okay, so moving into this second example. All right, so for this example, obtain the node voltage in the circuit shown below lah. So for this, obviously you have two nodes lah, all right, which is V1 and V2 here. Okay, so means that how many non-reference node? You have two lah, which is you have V1 and V2, you have V1 and V2. And how many reference node? You have this one lah, reference node here. And now you can define the node voltage, where your node voltage is actually V1 and V2. So you want to have this node voltage where you know that you have two voltage, so you need to have two equations lah. Okay, so the first thing that you need to know is that you need to have the two equations of that lah in order to solve for V1 and V2. Okay, so this is the answer lah. You can try. Okay, so okay, obviously for this, what you need to define first is the current directions. All right, so you need to define the current directions first. Okay. You need to define the current directions where this is the, from here you can define it as this current directions lah. Okay, so this is node 1, or we can put it as a V1. Here is node 2 where we can just put it as a V2. Okay. So for this, you have three branch here, right? Which one? This one is entering the node, this one is leaving, and this one is leaving lah. So we know that we need to have the current, positive current, equal to the leaving current lah. So let's say here, which is this is entering, just put the positive. Here, just put the negative. This one is the negative lah. So what you have here is actually, for positive side here, you will have 3 equal to the negative, which is leaving current, where you have I1 plus with I2, all right? I1 plus with I2 lah. And so now you have this equation, you just have to convert this I1 and I2 using the Ohm's law lah, where I is equal to V over R. Okay, so I here is actually just follow the directions of the current, where you know that I1 is actually V1 minus V2, right? V1 minus V2 over with 6. Okay, and for this I2, you know that it's follow the current directions here. V1 minus V0, V1 minus V0 over 2. So you have this equation, which is 3 equal to V1 minus V2 over 6, plus with V1 minus 0 over 2. Okay, just write like this and then simplify. Okay, again, like I show you before, you need to simplify. Like for this one, you can just times this with 6, I guess, and then you can just kill this denominator and then convert the equation into this lah. Simplify the equation where you have this for V1 minus V2 equal to 18. All right, and after that, we also need to get another equation at node V2, where we know that V2 is here, right? So the node V2 here, we know that this one is actually entering the node, where this one is actually positive, and this two is actually leaving the node, where this is negative lah. Okay, so like for this one, positive equal to negative lah. So the positive current, which is the I1, you know that I1 here, let's see, I1 equal to the negative, which is, this is 12 plus with I3 lah. 12 plus with I3. So you need to put the value for I1 here. So I1 is obviously is actually V1 minus V2 over 6. And for this I3 is obviously V2 minus 0 over 7 lah. V2 minus 0 over 7. All right. So you just equate all of this. What you have is this lah. Okay. You will have this as your equation. All right. And then after that, okay, you have this as your equation, then you can simplify this equation. Okay, just simplify this equation. This one, I think that you can just times with 42, okay? Or maybe the smaller number, okay? And then you just simplify, then you can get this lah as your equation. So you will have these two equation 1 and equation 2. So now you can solve for V1 and V2 lah. So this is the answer for your V1 and V2. Like I said before, you can use another method lah, where you can use the elimination method or you can use the substitution method lah. It's up to you, right? But here, I think for the next slide, actually, if you're not sure how to use this elimination method, I found this uh, website. I think there is a lot of website that using this elimination method calculator lah. So, but I found this one. All right, it's easier. Okay, so you can just, if you're not sure how to solve it, you can use this. You can go to this website and try to put, like for this one, of course you need to, it cannot read if you put the V1 and V2, right? So what you have to do is that you need to replace it with X and Y lah. So X for V1 and Y for V2 lah. Okay, so you can see how it solve it using the elimination method lah. Like for this one, you can just study the how to solve that using the elimination method. So then it will give you the value lah. Okay, where X is equal to -6 and Y equal to -42. But what is important is that in order to get the correct value, you need to have the correct equations lah. Like for this one, we need to get the correct equation for this lah, equation 1 and equation 2. If you get the wrong equation for that equation, so you might not get the answer that you are searching for lah. Okay. All right. So we have another example. This is also the same. All right. Okay. So I'll show you here the directions of the current. The first thing that you need to know is the directions of current here and also here. So obviously here we have V1 and V2. So you need to have two equations in order to determine the value for V1 and V2 here. Like for this one, it's have the sum of current leaving a node is equal to 0 lah, because it's only have the current leaving the node. So like say here the current positive and the current negative lah. So the current entering the node is 0. You don't have it, so you just put as 0. So you just have only the current leaving the node. So you just need to sum I1, I3 and I2 here. So this is all the current leaving the node lah, which is this is the negative lah. Okay, where this current is for positive is 0 lah, just put the 0 here. So then you can get this equation. Okay, just you can have this equation, and then again you need to simplify the equation. Okay, so just simplify the equation. So simplify this equation, and then I think that you can just times it with 4,000 in order to simplify this equation into this. And then after that, you have this as your equation 1 lah. Okay. And then after that, move on to the node 2 here, which is V2. V2 here, you have the positive current here 2 and then negative here. So you have the summation of current leaving and entering the node. When these three current leaving and entering node 2, it should be 0 lah. Okay, so what you have is it. So this one, I5 plus I6 is actually the current entering the node equal to this I4 is actually current entering the node lah, leaving the node. All right, so you just equal that and then just put it, so just you can just bring this current over here lah. And then you just substitute that with the Ohm's law, using the Ohm's law with the current, and then simplifies the current and simplify the equation so that you can get this. So now you have two equations. Okay, you have this as equation 1 and you have this as your equation 2. Okay, so what you have to do, okay, as I said before, you can use substitution method, elimination method, or as well you can use the Cramer rules. But Cramer rules usually you can use if you have 3 equations lah. Okay. So if you have these 2 equations, for this one it's use the substitution method. Okay, so you just substitute with this one lah. Okay, V1 is equal to 2V2 minus with 12 here. So this one is actually V1. So just substitute inside this equation 1. so that you can solve for V2 here. So V2 here, okay, you simplify. So then you can have V2 is equal to 96 over 12. So then you can have it as 8 volts lah. All right, so this is going to be 8 volts. And then you can substitute this V2 into this equation too lah. So V2 here, you substitute with 8. All right, so just substitute with 8. So then you now can have V1 as equal to 4. Okay. Okay, so okay, I think that I have 10 minutes more. I think that I want to go with this dependent source lah. Okay, so just now we have independent source, right? So independent source is actually, so if you found this source with the circle one, right, the positive, negative, so this is for voltage and this one for the current. So this one we call it as independent source, all right? But if you have this like a diamond source, right, this one we call it as dependent source, all right? So dependent source, if the circuit contains the dependent source, we call it this one as a dependent source. The node voltage equation must be supplemented with the constraint equation. So you need to have another equation when we call it as constraint equation, because dependent source is actually usually write with like for this current, it might put the for V node here, like for this one, it might put a 8 I node here. So this source dependent on this V node, and this source is dependent on this I node. So for this V node and like for example this I node, you need to come up with this constraint equation with this V node or this I node, for example lah. Okay, and then V node and this I node, you can get it from the circuit itself. All right. I think that you already go with this dependent sources, right? Before this on the previous chapter. Okay, so from this V node, for example, V node and I node, we can get it from the circuit itself lah. All right, so we call it as a constraint equation for this one. Okay. So for example, this circuit, right? So using nodal analysis, you need to find the value for V node. Okay, so this is the V node here. And this is actually your dependent sources, where this dependent sources is actually dependent on dependence on this V node lah. So this V node is actually here. Okay, so means that you need to come out this V node with the constraint equation first in order to solve for this V node lah. Okay, so what you're gonna do is that, okay, go for the next slide. So it's easy if you need to draw your current directions lah in order to solve for your node voltage. Okay, let's say here we put it as a V1 here, right? You have this node V1 where you have the current, it's all the current leaving, all right? So means that the summation of positive and negative. So means that for the positive, there is no the current entering the node. So here you just put 0. And then you only have this current leaving the nodes, all right? So what you can do is that, okay, so when you have the current leaving, all leaving the nodes, what you have to do is that you have I1 minus with I2 minus with I3 equal to 0, where this is the current leaving the node and this is current entering the nodes, where you only have this part. All right, and then for I1, it's actually this V1 lah. So I1, if you look at here, V1 minus 0 over 6 plus with 4, which is 10 lah. That's why V1 over 10 here. V1 over 10, which is 10 is 6 plus 4 lah. Okay, and then we have here is I3 here. I3 where you have not I3, I2, okay? I2 is actually V1, follow these directions. V1 minus with this 60 over this 20 lah. So V1 minus with 60 over 20, okay? Minus the 0 because this is your reference node lah, okay? And then another one, this current for I3 here. So V1 minus with 5 V nodes over 20. Okay, so you cannot solve for V1 because you have this constraint equation for V naught here, right? So you need to find what is the constraint equation for this V naught here. Okay, so V naught is actually okay here. You can see that V naught is actually here. What you can do is that V naught, you know that V is equal to IR, right? If you follow the Ohm's law lah. Okay, you know that V naught is actually equal to I1 times width 4. Okay, V equal to IR. So here I1 times width 4. Okay, and then you also know that your I1 here is actually equal to V1 over 10. Okay, V1 over 10 because here is the loop for I1 lah. So I1 here, I1 is actually V1 over 10. So what you can do is that you can just substitute this I1 here. So V naught equal to 4 and then substitute I1 here with V1 over 10. And then so that's why you have this V naught is equal to 2 over 5 V1 lah. Okay, so you got this value for V naught and then you can just substitute this value here lah. Okay, where you can substitute this value here inside this equation. When you substitute and you simplify, you get this equation. Okay, I think that you need to try to calculate it by yourself lah. Okay, so simplify, you get this, and then you know that your V1 is equal to 30 volts. When you calculate from here, you get your V1 is 30 volt, and then you can just substitute this value V1 here. So 2 over 5 times with V1 30 volts here, and then you can get your V naught is equal to 12 lah. All right, here is going to be 1, here going to be 6, and then you can get your V naught is equal to 12 volts. All right.